All right, so I'll make sure my mic back. Nice. So we did the basics of probability already. We did discrete and continuous also on YouTube. So in this session, I'll be going through the special discrete distributions that I think we went through last week. All right, so that like the binomial and the Poisson and all those kind of distributions, going through that now. So as I told you last week, knowing what the random variable is, basically what data you're collecting, and each distribution has a key way in which it is worded. So once you look out for those key parts of the question, you could automatically know what type of distribution you're dealing with. And once you do the distribution, it has an equation for the probability, the expectation, and the variance. And they might ask you some questions, calculate the probability x is more than 2, less than this. All those stuff come from we call the CDF, which is a cumulative density function, right? All those things comes from the distribution itself. The distribution has equations for each. So 80% of the battle can be really the question, and from what the question gave you, knowing, okay, based on this, the binomial. Obviously, if the question didn't tell you. But sometimes the questions do say using the binomial or whatever. Just make it easier for you. Right? So we went through it, I think there's, yeah, these questions here last week, like knowing what type of distribution it is. So we will do all those with actually doing the calculations with. But before that, let us lay the ground. You might have to take this down and write it down, but the video is there. So the first special distribution we'll be doing is the binomial. So for the binomial, the trick is the trials are finite. So meaning there's a fixed amount of trials and is out of a total. That's a trick that when you're reading the questions, I sort of would say, okay, given that 20 baseballs was true, what is the probability that 7 out of the baseballs do something? Is worded the same way, have a total amount of time they do something or total amount of time something can happen, and I want to know 8 of it, 9, 10, whatever it is. I sort of don't normally word the question. So that's still look out for that type of wording. And you could so that the first thing, but also give you the probability of a success. Right? The success is whatever the question deemed to be, right? So it's not really something that they really give you, but based on the question, you will know what is a success for the question. All right, these two things, anytime you read a question, you will automatically know, okay, this have to be a binomial. It can't be anything else based on the wording of the question. All right, so let me look down here for where we had a binomial. Right, so you can read this here. So a student takes multiple choice question with 20 questions. So that is a total there to give you. That's going through. Where each question has five possible answers and only one correct answer. Okay. So one question has 5 possible answers and one correct. So basically they're trying to give you the probability of a success there. So that's be 1 on 5. Because only 1 out of the 5 will be correct. So 1 on 5 will be the probability. They may not off rip just give you the probability. They might give you it in a sentence and you had to know, okay, probability is the successful outcome divided by the total amount of outcome. So you had to know that. But look how the word the actual question they're asking it. What is the probability that the student answers 15 questions correctly out of the 20? See how they're bringing it together? The one sum of a total, and they gave you the probability of a success. So looking out for those key stuff will always guide you through. Let's see if I have next. All right, look at this one. Survey finds that 60% of people prefer coffee over tea. Okay, so most likely that is the probability of a success. You want to know the probability that 6 out of 10, same wording. 6 out of 10, that has to be binomial. Anytime you want an amount of a total, is binomial. In addition to that, they gave you the probability of a success. Binomial on one side. Let's see if it have a next one. So website experiences 10% conversion rate. The site owner wants to know the probability that 2 out of the next 5 will make a purchase. 2 out of 5. That is binomial. When you want something out of a fixed total. So you either have a fixed total and you either have amount of that fixed total. An next example of a binomial distribution would be, let's say you're throwing a dice, like literally like rolling a dice, and you throw the dice 10 times, and you want to know the probability getting a 6. So let's say out of those 10 throws, they want to know the probability that if 4 of them were 6s. So you want to know 4 out of 10. All those distributions there will be considered a binomial. So you want a sum of a total. That looking at the word in itself, right? So let's continue. So that's the first piece. The other piece that you need to know, or the other pieces, is the probability x is equal to x. Remember, this is discrete, so it has no continuity here. It's discrete points. Right? So the probability x equal to x for a binomial distribution is NCX, right? Q, which is the failure, N minus X, N is the total amount of trials, right? And P, which is the probability of a success by X, right? This piece here, NCX or NCR is not the third, it's just N factorial divided by N minus R factorial, R factorial. This piece here you could do in a calculator for free. Yeah, you don't really need to stress about that. You could even do CNCR and CX in your calculator, right? If you look at your calculator, on the part with the multiplication, division, and stuff, you'll see NPR and NCR. So you can literally just do that part in your calculator. That part you don't have to stress out too much for it, right? So that's the probability of X, right? Then you have the last two, which is the expectation of X with the binomial, which is NP, which is the total number of trials by the probability of a success, and the variance of X will be NPQ. So number of trials by the probability of a success by the probability of a failure. Yeah, and that there is all you need to know about binomial. Right? You could ask it either way, either one is the same thing. Yes, you know, well, that's so you all will know, right? So I'll cover all the bases. This is where you will get your PDF from. Remember, a PDF for discrete does look like these things, right? At distinct points. Right, from here we'll get your PDF, and then the CDF is always the same, right? The CDF is capital F of X, and it's basically the probability X is less than or equal to X. This never gonna change, ever. Whether you're going continuous or discrete, this core concept never changes, and don't ever forget it. Once you remember this, you could do the CDF or anything. All right, so those 4 things committed to memory. Memorize the wording. The wording will set you free. Because the question you can't really word it any other way, especially when you go into the other distributions, which also have some keywords that kind of sell it out. When you put all that together, you can just read that question, you just know what distribution you had to use to answer the question. All right, so that is binomial. So let's do a question. It's hopefully I have enough space. Oh, I forgot one thing. Right. So when you notice that sum is a binomial, when you're writing down the random variable, this has parameters for it. So I'll just write that down here. So every distribution have a way to write it, right? So x, which is the random variable, follows a binomial distribution. And the parameters for a binomial distribution are n, which is the total number of trials, and p, which is the probability of a success. So this way, let's write the distribution, the binomial distribution, the random variable fit. You must write this first. Anytime you use a distribution, you must write the random variable first before you continue anything. Yeah, it's just good practice. Whether you're doing binomial, geometric, uniform, all the rest of them, just state the random variable first, which is the capital X, and then you continue with what you do. Once you know this, you will know when you're reading the question, you're looking for a total amount of trials and the probability of success. Yeah, it's the same idea that you would put over and over. So, right, now that out of the way, let's try a question. We'll just erase some stuff here. Limited space. Let's play it up and let's stop. Nice, so we have a clean question to look at. Shrink that font size. Alright, so let's go. So a student takes multiple choice, read this already, 20 questions each. So n is 20. Where each question has 5 possible answers and 1 correct. So 1 over 5, 0.2. That is the probability of a success. And also the probability of a failure will be 0.8 because P plus Q are equal to 1. Yeah, that's how it looks good. Right. In this case, the successful outcome is getting the question correct. It could be a question could come that the successful outcome is getting the question wrong. So in this case, the P that you will use is 0.8. All right, that's laying the base for it. In this specific question, the probability of a success was getting it correct. So in this case, it would be 0.2. But in some questions, the probability of a success might be the failure or getting the question wrong. In that case, it will be 0.8. Yeah? So we'll get into the habit of have to be the good thing in the question is the success. No, it could be the wrong thing could happen. In this case, getting the question wrong. All right? But anyway, so we have P. Our success is getting the question correct. So that is 0.2. What is the probability that the student answers 15? So this here is X correctly if they are guessing on all questions. Okay, no problem. They want to know the probability of 15 out of 20 binomial straight up. They didn't really give anything else substantial in the question to say is a different distribution you're using. So you write your random variable, X follows a binomial distribution where N is 20 and the probability of a success is 0.2. All right, that's the first thing. Second thing we do, we answer the question. So what I want? The one the probability X is exactly, you never say less than or more than, so you have to read the question properly, right? So exactly 15 will be the probability X is equal to 15. So that will just equal to using the equation. So N is 20, C, X is 15, so Q, N minus X. So if we go back to the equation, it's N minus X. So N minus X will be 20 minus 15, which is 5, and P, X, which is 15. So the trick in this, obviously I could plug in what Q and P is. So Q was 0.8, and then P was 0.2. So how about the trick in this? I'll show you. When you're writing it, just to make sure you go in the correct way, the top pieces just add up to equal to this. Clearly see the piece. And whatever the bottom here will be on top in terms of what the success is. So whatever here will be on top here, and the sum of these two will give you the top piece. That's how it does come together. Right, so that's how we can look towards. But that's using the equation. N, you know what N, that is the parameter. And you know what P is, one of the parameters. So they want 15, so that's X. That's plugging it straight into the equation. And you get this here, so you end up with this here. And you can just plug it in a calculator. So 20, so 20 shifts. You can look for the C. So it'll be 20, say 15 So it'll be this here. Then you multiply that by 0.8 to the power of 5, 0.326768, and then 0.2 to the power of 15. It's a very small number. So you multiply that by 0.32768, multiply by 155. Right, so that's a very small number. Right, and that'll be the answer. Right, so probabilities add up to 1. So it should be less than 1 when you do the question. If you get anything more than 1, you just know you go wrong somewhere. All right, and that'll be the end of the question. Really asks too much. If you wanted to get the expectation, the expectation, it will be n, which is 20, by p, which is 0.2. So 20 by 0.2 is 4. The one to the variance will be the n, which is 20, by p, is 0.2, by q, 0.8. So 0.2 by 0.8 by 20, and you get it. Yeah, with that said, so we did probability, expectation, and variance. Right? And that there is straightforward binomial distribution question. Right? So let's see if we can try the other one here. So that's doing it quick ups because you know how the question is worded. They gave us this probability, a probability here. We don't know if it's a success or failure as yet. So they said 60% of people prefer coffee over tea. Okay, so that gave us a probability. We don't know if it's a success or failure as yet, but we will just write P for now. They want to know the probability that 6 out of 10 random selected people prefer coffee. Okay, so in this case, this will be the success. What is the probability that 6 out of the 10, no problem, prefer coffee? So the X follows a binomial distribution. N in this case is 10, and the probability of success is 0.6. And they said exactly 6. So the probability X is equal to 6, is equal to 10 C6. So it'd be Q, which in this case will be 0.4. If I add up to 1, so it'd be N minus X, so it'd be 4 by 0.6 to X. All right, so I need to put that in a calculator. 10 C6, so that'll be 210. Especially for the whole thing, yes. And so it'll be 210 by 0.4 to the power of 4 multiplied by 0.6 to the power of 6. So this one you get out 0.25. And that'll be the probability. Straightforward. Nothing else to cut up your head with. Alright? And that there is 2 binomial distribution questions. Right. I think it had our next one, but it cannot be redundant at this point. Because basically the same thing you do. Right, so let's move on to another distribution. I want to go to a whiteboard. Right, so the next distribution that we will come across is the Poisson. I don't know how to pronounce it properly, but see how good I could spell it. Right, that spelling might be wrong. Spelling is not coming for the exam, which is a good thing. So that's why I don't know if we could use the distribution. All right, so this distribution here, from a recap from last week, it's similar to binomial in terms of how to word the question, but the one sole thing that I just kick this one out of the ballpark is that it have to happen in an interval. You have to keep that in mind. So also have to do with intervals, a fixed interval. So it had to be fixed. So they might say the 10 bus pass traffic light in 2 minutes. Out of the 10 bus that pass, was the probably that 3 red. So it's something like a binomial. So it's 3 out of 10. But the one thing that I say in the question that I just make sure it's possible is that I say in 2 minutes, in 5 minutes, or they might say the average in might be lengths, average in 10 millimeters. They might tell you that specific piece. That was kind of tricky. So they go back to this here to see if we have any possible. So you can see exactly what I'm talking about. So look at this question. Look at the part where they say the interval. They will give you some type of interval. They might say an average. I will show you what they mean by the average just now, but let's look at it for the key words that it does use. So a hospital emergency room receives an average 3 emergencies, okay, per hour. Look at the interval. They give you a next interval there. So the probability of receiving 5 emergency class cases in an hour, they give you a next interval. What is the probability that the emergency receives exactly 5 in the next hour? You see how it's similar to binomial, but they're giving you an interval. That interval doesn't make sure it can be anything else, because nothing else, no other distributions have anything to do with intervals. And so possible that'll be the easiest thing to see. Yeah. So just looking at it, you can see, yeah, possible. Let's see if we have our next one. Right, this one here. So look out for the interval. A bookstore sells on average 4 rare books per day. The manager wants to find the probability of selling exactly 6 rare books in a day. What is the probability that the bookstore sells exactly 6 rare books today? So you see in the constantly giving you that interval. Yeah, so that is something to keep in mind. How an interval. Cash is in it. Once you see it, you know what you're talking about. I even go back to the tutorial I think this number 17 is small distribution. I kind of give you the parameter, but I said don't worry yourself. So the number of telephone calls arriving at a switchboard during a 10-minute period. How to be possible? And they get the thing afterwards. So there's an I, okay. Right. Yeah. Possible. Period. Interval. They're literally giving it. Even if Miss didn't tell you it was a possible distribution, it kind of help you out. But they give you an interval. Yeah, on the time you hear interval, you know you're setting up the possible one time. So let me just see if I spell that correct. All right, so mix up. So it's POI. So I'll swap the I. All right, say less. So you had to go before. Aha. Right, okay, no problem. So that about interval. So let's go through the stuff. For the first thing is the random variable. So X follows PO. And the parameter for also is lambda. Yeah, lambda is that's the average in the interval. Whatever interval they give you, like basically what lambda is. So any question before they kind of gave you what lambda was, because they say on average, they basically giving you lambda. Yeah, so pretty much it. Right, slam. This one is kind of the easier one. The probability of the PDF equation that's true people off. There's the way this one. So it's e to the minus lambda by lambda x on x factorial. Yeah, so it's the way of this equation in terms of finding the PDF. But remember, it's discrete, so it exists at specific points. All right, so that is where you get the PDF from. And last one, what does make the puzzle real nice is that the expectation and the variance x is both lambda. So if any question asks you, what is the expectation of variance for a puzzle distribution, it's just lambda. So no big equation, it's just lambda. All right, so it's something to keep in mind so you will know 3 marks. So we have the random variable, the PDF, and some extra stuff just in case they ask you. And key, the golden thing that we're looking for is the interval. Once they give you the interval, most of the time it does give you what the average is, lambda. All right? So you could do factorial in a calculator. Uh, so my advice is to make sure you know how to do it. My calculator different from yours. So just look on your calculator, you might see something looking like x factorial somewhere on top where you had the sine and cosine and stuff. Just make sure you know how to use it. In addition to the NCR button, which does normally be around the multiplication and division signs. Yeah, make sure you know how to do those two. Because it will help you out a lot. Trust me. All right, let's go on to you start with this one, since I already on the page. So reading the question now that we kind of know what the random variable and stuff is, a bookstore sells an average of, so we know this is lambda, and they give us an interval. Okay. The manager wants to find out the probability of selling exactly 6 rare books in a day. Okay, what's the probability of exactly 6? Okay, no problem. So we know X follows a constant distribution and the parameter is lambda, which is 4. Fair enough. The probability X is equal to exactly 6. So we can just plug this in the calculator. So it'll be E to the minus lambda by lambda x divided by x factorial. So that whole thing can just be negative. So shift E minus 4 multiplied by 4 to the power 6 divided by 6 factorial. All right, so this will be 0.104. That is all for that. Let's try the next, well, another one. Let's try this one here. So we have, let's look at the wooden kind of, okay. So hospital receives an average of 3, so there's lambda per hour. So we have the interval, the probability of exactly 5 emergency cases an hour is calculated. What is the probability that the emergency room receives exactly 5 cases an hour? Okay, interval, interval, interval. So we had it have to be possible for sure. And the lambda is 3, by the parameter. So what I want, probability x is equal to 5. Plug it in. So it'll be e to the minus lambda by lambda x divided by x factorial. So it'll be shift e to the minus 3 multiplied by 3 to the power 5 divided by 5 shift factorial. This will be 0.1008. All right, now, if that asks for the expectation of variance, it's 3. Mind blown. All right, so that is Poisson. So we did binomial, so that is our sum of our total only, our sum of our total. Poisson is how much time something happened in an interval. That basically all of us ask for. Yeah, how much time something could reoccur in a certain amount of time, length, it could be anything. The interval could be anything. See it? So a common example where we use like a Poisson distribution is like a production line to know like the probability of like defective stuff passing. So they might say the probability sorry, on average, 3 defects are seen in 10 minutes. That's how they will state it. And then they will say, what is the probability that 10 defects pass in the same amount, the same interval? But they can't change the interval. That'll be the same interval. All right, and from time to get intervals and thing, we're talking about Poisson. So let's try the one that let's give, oh, let's write the equation. So we don't have time to do the actual maths. So the number of phone calls arriving at a switchboard during a 10 minutes period is known to be Poisson random variable with x and parameter 2. So x follows a Poisson distribution with lambda being 2. Okay, what is the probability that more than 3 calls will arrive during any 10-minute period? So we know the sum of the probabilities how to add up to 1. Knowing that, this kind of help you out when I give you like these less than and more than questions, right? So the probability that x is more than 3. So, okay. So we know that the sum of the probabilities adding up to 1. So we could take full advantage of that. So this would just be 1 minus the probability x is less than 3. Well, since it said more than 3, so more than 3 will start at 4. So therefore, it had to be equal to 3 here. Yeah, just be careful with these inequality signs, because they're kind of tricky. So when they say more than will start after, right? If they say less than will start one less. If they say equal to, it will include the number that they write in the bracket. So just be careful with that. So the 1 minus everything less than 3 to give you more than 3, right? So we could do something like this. So the 1 minus the probability x is equal to 0 plus the probability x equal to 1 plus the probability x is equal to 2 plus the probability x is equal to 3. So what you have to do now is in a calculator, just show you how to find this one, which is using the equation. Remember, probability x is equal to x is e to the minus lambda, which you know already, by lambda x, which you know already. X in this case will be 0, 1, 2, and 3 divided by x factorial. So you have to rinse and repeat this equation for 0, 1, 2, and 3. You add up all of them, and then 1 minus that will give you this piece here. Yeah, as I will approach that question. I kid you not, knowing that is some of the probabilities adding up to 1, just thinking about that, you most of the time we get the correct answer. And do I have enough space with the, well, the probability that no calls will arrive, no calls is just 0. So I mean, if it's 0, it'll just be kind of a weird question to ask. It needs to be minus lambda by lambda x factorial, right? 0 factorial is 1. So this will just be e to the minus lambda. Why? Because anything to the power of 0 is 1, and 0 factorial is 1. So it will just end up being this. So I guess it's like 3 marks in a way. I don't see the point in that question, but yeah. So that was the first question. Number 18 is a exponential, which we'll get to. We have 15 and 16. So I'll let her run through it, but I could do the maths thing after. So I'll do it up here. So 15. A binary so generate digits 1 and 0 randomly. Okay. Probability 0.6 and 0.4. So far they just gave us the probability again at 1 and a 0. Okay, no problem. What is the probability that 2 ones and 3 zeros will occur in 5-digit sequence? Okay, so what they gave us a fixed amount. They never give us any interval or time or anything. So it can't be possible. Yeah, they never word the question like that possible. So it can't be that. Uh, and they want something happening in a fixed amount. All right, so in this case here, we could say the 5 is n, like the total, and then we have 2 ones and 3 zeros. So let's say normally a 1 is considered a success in most cases, because logically speaking, when a 1 happens, something that I wanted to occur actually happen. So we could just use 1 as a success. So therefore, with all the information, this will have to be a binomial distribution with the parameters being n as 5 and the probability of success is 0.6. All right, so the probability that 2 ones, so that basically probability x is equal to 2. So that would just be, so A probability x is equal to 2. It will be 5c 2 q, which is 0.4, n minus x, which is 3, by 0.6 by x. So the top adding up to 5, everything looking good. You plug that in a calculator, and you'll get that answer. right? And then B, what is the probability that at least 3 ones will occur? Okay, so 3 ones. All right, so at least. So they said at least 3 ones. So that is more than or equal to 3. That is what I'm asking. So the probability X is more than or equal to 3. But they say at least 3. So it's 3 or more. So in this case here, we could take advantage of what we did for the last piece. So it'll be 1 minus the probability X is less than 3. It can't be equal to here because the equal to in this one, it include any 3. So we had to start 1 less. So it will be 2, 1, and 0. All right, so it will be 1 minus probability X equal to 0 plus the probability X is equal to 1 plus the probability X is equal to 2. And these pieces here, you know how to do it already. You just rinse and repeat it into the n cx q to the n minus x p to the x equation. And you just calculate it. Remember, it's discrete, so it will have a value for each distinct point. You add them up, and then 1 minus it, and you get the answer. So always keep in the back of your mind that the sum of the probabilities adding up to 1. So you can massage it in different ways to get different subdivisions of it. If they say probability X is less than 9 or whatever, you could do that. Because remember, for binomial, you know the maximum amount of trials, and you know it adding up to 1. Yeah, so another weird one. Let's say I had 10 trials, right? And you want to know the probability X is less than or equal to 9. So you may be tempted to do 0, 1 straight up to 9 and add it up. Yeah, that will give you the correct answer, but that will take very long. So since you know the sum or n is 10, you could just do 1 minus the probability X is equal to 10. Okay, you're carving it out. So if you eliminate 10, you will get 9 straight down to 0. So those sort of stuff, like knowing that, will help you out a lot in these questions. Trust me. And in extension, any other distribution. Because when you say that would change with each distribution, that's how we calculate in the PDF. All right. And it does have 16. So a noisy transmission channel has a per digit error of p is equal to 0.1. So they give you a probability of a success. Calculate the probability of more than one error in 10 receive digits. So that's basically falling in line into what we do for binomial. We want something of a total. So if x follows a binomial, parameter n is 10, and the probability of success is 0.01. Notice the difference for puzzle. They never say nothing with average in a certain period. They never say nothing like that. So it can't be that. As I said, once you know how they word the question, your best bet will always be the correct answer because they word the questions similar, extremely similar. Look at the difference between 16 and 17, like in way how they word it. They give you a, if you say the word, all right, and they give you like some average or something, they will keep on telling you that in the question. Because possible is the interval specific. All right, well, this one here is this is a simple rinse and repeat. Because I just want to know 1 and 10. So it'll be 10 C1. Q in this case is 0.09, no, 0.99. Is 0.01. N minus x will be 9 by p, which is 0.01 to x. Plug that in a calculator, so that probability x is equal to 1. Plug that in a calculator, and you will get the answer. That is all that was. All right, so we did Poisson, and that was the Poisson distribution. All right, so going on to some notable mentions. So we have the geometric, which is the selfish one because you only really care about the first time it happened. He didn't really care about nothing else. And so I just remember it. So for geometric, he only cares about when it happened the first time. The first time it happened. Remember this. They will say it was the probability that it happens on the second time you do something, third time. Think of it as, how to say it? You're trying to win like a cake, and it's like, every time you buy something, they write down your number, something like that. So they want to know, okay, if I was to buy 10 tickets, what is the probability that I gonna win this tournament on the fifth ticket? That is the geometric. They want to know when the thing actually will happen. They don't really care about nothing else. The thing in this case is the probability of a success and the success actually happening. That happened in the first trial, the ninth trial. They just want to know when the thing could happen. This is basically lottery. Basically, this is lottery. All right. Okay, so geometric distributions. So the word in the field, they want to know in n trials, when will something happen first? Yeah, was the first time I got like basically word in for geometric distribution. All right. So first thing, the PDF. Remember the discrete. So it's still equal to x. So it's 1 minus p by x minus 1. Right? Then you have the expectation, which is 1 on p, which we should know already because from the dice. And then 3, the variance, is 1 minus p on p squared. Right? And yeah, obviously that is the truth that you need really for geometry. All right, Miss doesn't have any geometric questions in the tutorial. So at this stage, really, I'm not gonna say it might come, but it's very unlikely that it may come. Because if I'm being honest with you, if you bring in a question, whoever sat in the paper, it will either be binomial they will bring, Poisson, or they will bring the normal distribution. Because those questions are the most room for actually doing a question. Geometric and uniform, it's too easy, as you will see, because those things that the probability of a success or a failure is the same throughout. It have no different probability x equal to 4. It have no different probability is the same. So it's just too easy to bring in a finals. If you understand what I mean. It won't have any thinking in it. Once you memorize what it is, it's straightforward. This might probably come from midterm or something, but highly unlikely. Because even this tutorial didn't have a geometric question, like a question where they laid it out and stuff, but didn't have it. So it's, I'll be honest with you, just make sure you know normal, binomial, Poisson, those three for sure. Make sure you know them. So we'll bring questions on that as you saw in the final part of the probability tutorial. Right. I'm gonna do the last one time. Uniform. So uniform is exactly as the word says. Right. So the uniform is kind of look something like a box. Look like that. It's the same straight through. Never change. And it's 1 and b minus. Right. So there's always a rectangle. So just think of it as a rectangle. And you notice the probability never changing. There's a flat line through all x values. So it just wouldn't be as practical to bring in a exam, like a final exam. All right, so things you remember in this one, the PDF. So the PDF is like a piecewise, right? So f of x. So let's go like this. So it's 1 on b minus a, and then 0 otherwise. What I mean by that is, like we say, my values of x running between 1 to 5. So when I draw my little PDF, it will be 1 here, and it will be 5 here. And then it will just exist in between these 2 points. And it will be 1 on B, which is 5 minus A. So that will be the probability of all in between. Remember the discrete. So 1, 2, 3, 4, and 5 will be the same throughout. So that's what I mean by 1 on B minus A. For anything in between, so you can say x is less than or equal to b, and more than or equal to A, and it's 0 otherwise. Yeah, that's how it does list out the uniform distribution. It does look like a rectangle, literally. All right, and then the second thing, expectation is A plus B on 2, and then the variance is the ugly one, so it'd be B minus A squared all over 12. Right, so that was the two things you need for these. So you have the PDF, expectation, and the variance. The reason why the uniform too easy is because once a call, what's the probability x is equal to 2, 3, 4, 5, 1? It's the same thing. It's just 1 on B minus A because it's uniform. Same. It's like rolling a dice. The probability of getting any number on the dice is the same. It's 1 on 6. It's not gonna change much. Yeah, so it's have no variation in the question. So that is where I don't know for the uniform distribution. Let's see if I have anything else. Right, yeah, so one more. That's to cover all the bases. So the last one is the exponential.
Wait, why the variance being divided by 12?
Right, so the solution to that question there is a proof. So I doubt you I'm going to go through the proof with you, and because that will take a while. Because you must never ask you for the proof for it. All right, but in this case here, if you go back to the equation for variance, so remember variance of x is the expectation of x squared minus the expectation of x all squared. So what it basically did is that this equation here, so the x squared part just went back on top and the square this to get expectation of x squared, and then this part here they went and square it again, the overall answer, and then they bring it together and then end up with this. Yes, it's just a derivation of it. But you don't have to worry about that too much, right? But that's how they derive the values of it. So think of it just like it did for discrete, how you get expectation of x squared in the bracket. So let's just show you. That's the way to be too confused. 0, 1, 2, 3. So remember, this is uniform. So therefore, the probability of all will be the same. All right, so let's make it even so you can add up to 1. So let's say 0 is 0. This is a quarter, a quarter, a quarter, a quarter. Okay, the uniform, right? So if I want the variance of it, you can do like normal. So the first thing you need is x squared. So you need the expectation of x squared. And remember that is the sum of x by the probability x is equal to x. And you just go 1 by that, this by this, and you keep on going. So x squared now will just be the sum of x squared by the probability x is equal to x. So you'll have square these on top here and multiply it by these, and you'll get this piece here. Then you subtract the expectation of x, which is just the sum of x by the probability x is equal to x all squared. So that would just be this by this, this by this, this by this, this by this, and you plus it, and you end up with that. This equation here is the variance equation. So what they did to get the derivation but it's kind of long. So it will take probably like a good while to do. What they did basically is the equation for the expectation here for this piece here. This is just E of x. That will give you this piece here squared. So once you square that, you will end up with this piece here. But what it did now to get this piece here with the x squared from the graph itself, these points at the bottom here, the 1 to 5 or the A to B, they just squared. So you end up with A squared, B squared, and they just did the same equation here. So you end up with A squared plus B squared on 2. And all they did there is just bring it together on one side and end up with the 12. Yeah, is that proof you don't need to know, but that's just how they get it. to ramble on. Anytime you're stuck with calculating the variance or anything, just remember this equation. It will always save you in here. Alright, so that is something to remember. Anyway, so for that. So the exponential one is your last one. Well, last in discrete. The unit continuous distribution must required us to know is the normal. So as the unit one really hard to know. And the questions for normal are the easiest because it doesn't have much calculations. It's more like proofs. And so yeah, it's more proofs. Like the proof for the Earth, sea, the all those stuff. It's majority of the proofs for coming. All right, so the exponential equation, it's similar to the Poisson distribution, but this one happened in between intervals. So what I mean by that is, let me go back to actually read the question that Miss I did for the exponential. So they said, assuming that the length of a phone call in minutes is an exponential random variable with parameter 1 and 10. So lambda is 1 and n for the exponential, right? If someone arrives at the phone booth just before you arrive, find the probability that you will have less than 5 or between 5 and 10. So with these things here, with exponential, is a very weird distribution. If they're bringing it, they have to tell it. Because sadly for this one, it have no like fixed sentence that I could tell you. Say when this one probably the trickiest. But by elimination, F is not binomial, Poisson, uniform, geometric. It's hard to be exponential if in the exam. Yeah, and they will normally word it correct. So the other thing I could look out for is a lambda. Lambda could only be for Poisson and exponential. So that will eliminate some. And you know, for Poisson, you're looking for something in a period of time. Right? The trick for exponential, what I notice is when they give you the question, compared to the Poisson, they're going to ask you the time itself will change when you do it with the exponential. Remember, for the Poisson, the time never change. The intervals stay the same. But for exponential, the intervals just change. So they will change the intervals for you. That's how you look up it. All right? So just keep that in mind. Poisson, interval doesn't change. It's had to be the same interval. But for exponential, it could be 2, 3 minutes, they could change the interval. Yeah? The interval is the dependence, it changes as a result of something else. For Poisson, the interval independent, however, it doesn't change at all. All right, so let's go back to and finish all this. So the first thing, the PDF. So lambda. So we already random group. So x follows our exponential. So you have 1 on n, which is lambda. So it'll be lambda e to the minus lambda x. So that'll be the PDF. So lambda is 1 on n. And it's like the number of trials and so forth. Second thing, you have the expectation of x. And you have the variance. I think this one have those stuff. This is why this one to bring it so much. All right, so thing you had to know about this one, CDF. So like capital F of x. So that's 1 minus e to the minus lambda x. All right, and this will give you less than because it's PDF, CDF, sorry. All right, so that's really all I had to know for exponential. It doesn't really change too much in terms of the question. Lambda is the parameter, and x is what I want because it's discrete. And this here is your CDF, and obviously this gives you the probability x is less than or equal to some value. All right, and then just for good measure, the probability x is more than something. That's the opposite of the CDF. That's help you out. it will just be e to the minus lambda x. So you have the CDF, which is less than or equal to x, is 1 minus e to the minus lambda x. And then just for good measure, you have the probability x is more than x, which is e to the minus lambda. So that is some nice equations that you could remember as to not triple too much, right? But if I have to give a trick in terms of expectation and variance, real important. Anytime they give you any distribution, it is discrete, which means I could plot this table. Yeah. If you ever confused as to what the question asking you for or how to get it, just plot the table at the discrete points. Just get your probability x equal to x and x, and from here, you know where to go. Then you know the equation for expectation, the sum of x by the probability x equal to x. You know the variance, and you could go from there. Right? So just some equations, some distributions, you could get the expectation and variance from one nice equation. Right? So let's try the question that this teach. Let's give us here. So we had already read the question, so we could label the distribution as a exponential, and they gave you the one on n, which is lambda. So 1 on 10 is like what, 0.01, I believe, 0.1. Yeah, 0.1. All right, so that's the random variable there. So they said if someone arrives at a phone booth just before you arrive, okay, whatever, find the probability that you will have to wait less than 5, between 5 and 10. Okay, so that's drawing the graph. So this is for the PDF. So remember the PDF is the common f of x is lambda e to the minus lambda x. Right, so if you're sketching this here, it will look like this exponential. It won't touch the x-axis. So this how it does look. This appears lambda. So this how it does look visually. All right. So the question asks is less than 5 minutes. All right. So there, anytime they give you less than all these sort of stuff, that basically they're talking about the CDF there. Right? They're not really hiding it too much. So we could jump to the CDF and we have the equations that we're doing. So say part A, the one the probability x is less than 5. So that will be the trick. Probability x is less than or equal to 4. Remember, when you're using CDF, it must be in CDF form, where it have the less than and the equal to. Don't fall for the trick. Okay, you might have go and put 5 in the equation and get the question wrong. So less than 5 starts at 4. So it could be less than or equal to 4. So don't fall for it. And that is based off the CDF, and we know the equation for that is this here. So that'll be 1 minus e to the minus lambda x. So it'll be 1 minus, so minus lambda, so minus 0.1 by x, which is 4. And you plug that in a calculator, you get the answer. All right, that is all it's offered straight on. And then this one here, between 5 and 10, I might need more space for this one. So the one to know the probability is, make sure I read it properly, between 5 and 10. So if we draw the graph for it, right, so there's like a sketch. So we know, let's say 5 here and 10 here. The area on that, or the total, sorry, not area, it's not area. The total probability adding up to 1. We know that. So total probability is equal to 1. That never gonna change. Right? So between 5 and 10, so 10 here and 5 here. So if the one between 5 and 10, that means if I write it as a probability, it had to be less than 10 and more than 5. I basically what that asks me. Probability x is less than 10 and more than 5. So that is basically in the layer, which is your red piece. So that basically it. So think about it. Remember, we can massage this here. The total probability adding up to 1. And we have the equation for the probability x is more than x, which is e to the minus lambda x. And we also have the CDF equation, which is the probability x is less than or equal to x, which is 1 minus e to the minus lambda x. We have these two equations for exponentials that would give us different regions of the graph. So if I was you, what would I do? I would try to carve out what I don't want. So the first piece I don't want is this piece here. I don't need it. So that would be this piece here. Right? So that would be the probability that x is less than 5. I don't need it. Right? I'm writing that less than, I can make that into a CDF. So it'll be the probability x is less than or equal to 4. So I don't need that. So I'll just write it here. So we piece it together. So less than x, more than 10. So it'll be 1 minus this piece here that I don't want. So when it's less than is the CDF. So it's 1 minus e to the minus lambda, which is 0.1 by x is 4. So that's our first piece. Next piece I do not want is this piece here. And I don't need it. And that is the probability x is more than 10. I don't need to talk it, subtract it. So that would be subtract, and we could use this one here. So it would be e to the minus lambda by x, which is 10. Right, so I already covered the two pieces I don't need. Obviously, I'm not going to do the maths, but when you subtract and do whatever you have to do here, plug it in your calculator, you'll end up with the answer. Because at time I'm not going to do the math stuff, but that's just the general idea. Right, and like I say, we'll do those two questions by just rinsing and repeating these two things here. Just remember, make sure it's in the form in terms of the inequality signs. Just you might plug in the wrong value of x. So if they say less than 5, that means it's less than or equal to 4. It's starting at 4. All right, so if they say more than 10, that means it's more than or equal to 11. Let's make sure you're using the correct form of the equation for the CDF. That's very important. All right, and that is 18. All right, 19 is our proof. It's more like maths. Or comes with our decimal power 10. All right, but so far we did 15, 16, 17. So we did the binomial, the Poisson, and the exponential distribution question. And yeah, so let's see where we are at. So I did the distributions. So those distributions that I did there are the main discrete distributions. So you have the binomial, something of a total, you have Poisson, something happened in a period of time, you have your geometric, the first time something happened out of n trials, and you have a uniform, which, oh, I could write it. Uniform is the probability of each outcome is the same. That is the trick that has sell out the uniform. Yeah, this is the trick. Let me see if I get a uniform. So a random number generator is used to select a number between 1 and 10. So remember, let's look like a rectangle. 1 here, 10 here. Each number has an equal chance of being selected. Wow, uniform. From the time they get it as uniform. So that means the graph will look like this. Yeah, that'll be it. It'll look like a rectangle. Yeah, that is the trick for the sentence or the phrase you look for the uniform. The probability of each outcome have to be the same no matter what. Yeah, each section has an equal probability of being landed uniform, straight off the bat. And the parameter for the uniform, well, you know, is 1 and b minus a, which is p. All right, so in this case, 1 and 8, b and a. All right, all right. So that is the distribution. Those are the discrete distribution. So we did how to get the expectation, the variance, plotting the PDF, and the CDF for discrete. Remember, discrete are just vertical lines. Yeah, is the easiest one to get the CDF for, but all of them just gonna look like horizontal lines. All right, so That is the end of the street. All right. Let's see if I could. Okay, a question. I got actually before I do. Because the question will be long. But just out of curiosity, your want me to do number 19? Let's see where's the, or it all just want me to continue to, I was going to do this question here with this CDF. So, what you all want to do? I don't mind doing it. It just will take longer to do. Just stop the recording.